Hi, Assalamualaikum. How's everyone? I hope everybody's well. So, welcome to my lecture number 12 for CHM477 Inorganic Chemistry. In my lecture 11, I stopped here. And this is at the end of lecture 11, I asked you to go through example 22.2 and example 22.3. I hope you have gone through that, and I hope you understand everything that is explained in this worked example. So very quickly, this species here, NiCO4, is tetracarbonyl nickel 0. Tetracarbonyl nickel 0, because this nickel is a 0 oxidation state because the carbon monoxide carry with it 0 charge. So there is no charge on the nickel. In here, you have sodium, gold. You have sodium, gold, and 4 fluoride. So you name the cation first. It is sodium tetrafluoro. Why I don't say tetrafluoride? Because as a ligand, the fluorine must have an O at the end. So fluoride becomes fluoro. So it's sodium tetrafluoroorate 3. How do I know orium has an oxidation state of 3? It is because this sodium carry with it +1. This 4 fluorine or fluoride carry with them -4. And the whole thing is neutral. So you have to have the orium having 3 plus charge. So 1 plus 3 minus 4 equals to 0. So orium or the gold has a charge of +3. So it is sodium space. Sodium is the cation, so you name the sodium first. Sodium space tetrafluoroorate 3. Yeah, there you go. Sodium space tetrafluoroorate 3. Why we don't say aurum or we don't say gold? Because this is a negatively charged complex ion out there. And the negatively charged complex ion, all the metal will be ending with the ATE. Yeah, with ATE. So its orium becomes orate. And for this one, it's potassium space hexacyanoferrate 3. Why ferrate? Again, for the same reason, because it is this whole thing is in the square bracket is negatively charged, so it is ferrate. And iron here is a +3. How do I know +3? Because 3 plus 3 minus 6 is equal to 0. The whole thing carry with it 0 charge because it's a neutral compound. So potassium hexacyanoferrate 3. Yep, potassium hexacyanoferrate 3. Sometimes it's given a common name of potassium ferricyanide, but that is not the name that is following the convention of IUPAC, IUPAC. Right, and number D here, you have, this is a different story. Your complex ion now becomes a cation. Why do I know that the complex ion is the cation positively charged? Because the counter ion is negatively charged. There are 3 chloride there. So it is it is neutralizing the charge of the counter ion. So the counter ion is 3 plus. So we say this as ethylene diamine. En is ethylene diamine. So you don't say bi-ethylene diamine. You say you don't say tri-ethylene diamine. You say tris ethylene diamine. Remember the rule that we went through in the previous lecture. So tris ethylene diamine chromium 3 space chloride. You don't call this chloro because chloride here acts as a counter ion. They don't act as ligand. So as a non-ligand, you call it chloride. But if that chloro is within the square bracket, then you call it chloro. Yeah. So tris ethylene diamine chromium 3 chloride. There you go. Tris ethylene diamine, remember, put the bracket around ethylene diamine telling us that the ethylene diamine is 3 times. Chromium 3 space, there is always a space between cation and anion. Here is a cation, this is your cation. Yep, cation, space, anion. Cation for potassium, a space in the middle, and your anion. Yeah, right. So that is example 22.2. I hope that's all right. Oh, how do we name this one? This is quite interesting. You have Cr, water 4 times, chloro 4 times, and chloride 1 time. There is a difference. These two are chloro because they are within the square bracket, so they are acting as ligands. But this particular chloride is not acting as ligand, it is acting as counter ion, so we don't call it chloro, we call it chloride. So what is the oxidation number of chromium here? So chromium is X. We don't know what it is, the oxidation number. Water is 0. This chloro is minus 2 because there are 2. And chloride is minus 1. So x plus 0 minus 2 minus 1 is equal to 0 because the whole thing is neutral. So x is equal to plus 3. So we know this is chromium 3. So how do we name this species? You name again the cation first, and within the cation, you name the ligands. And if there is more than one ligand, you mention the ligand according to alphabetical order, not counting uh, the the number of how many times. So mono, di, tri don't count. So you just look at the ligand's name. So this ligand is called aqua. This ligand is called chloro. So aqua must be mentioned before chloro. Then you mention the metal and then space. Then you mention the counter ion. So it's called tetra aqua dichloro chromium 3 space chloride. Yeah. Tetra aqua dichloro chromium 3 space chloride. So let me write that down. Sometimes tetra aqua, because there are 2 A's there, you just get rid of 1 A, make it tetra aqua. Yeah? Tetra aqua, that's the tajweed. Tetra aqua. Oops, excuse me. Tetra aqua, no space, dichloro. Chloro because it's a ligand. Chromium, there is no space. Chromium 3. And let me make this longer. Chromium 3 chloride. Yep. And in some textbook, you may find it written as get rid of this one of the like that. Tetraqua dichlorochromium 3 chloride. Either one will be equally correct. Yep. You can say tetra aqua dichlorochromium 3 chloride or tetraqua dichlorochromium 3 chloride. Yep, don't forget the space, don't forget the oxidation state, don't forget to mention the names of the ligands alphabetically, in alphabetical order. Yeah. And example 22.3, it says, according to the name, give the formula. You have penta-amine chloro-cobalt-3 chloride. So you have 5, amine is ammonia. So you have 5 ammonia, 1 chloride, cobalt 3, and then chloride outside. So you name it, you write the structure like this. Yeah. The cobalt, the 5 ammonia, the 1 chloro, and the 2 chloride. And how do I know to put the chloride as 2? Because you have to work out how many does that complex ion need. Because cobalt here is cobalt 3. Yeah, cobalt here is cobalt 3. Chloro, there is only 1 chloro. So, and amine is 0. So that charge of pentamine is 0. The charge of chloro is -1. Cobalt 3 has a charge of +3. This chloride must be 2 because 0 minus 0, excuse me, 0 minus 1 plus 3 minus 2. Yep, that's how you balance the charges. Yep, so you go through the explanation given in here. Similarly, with the question number 2, you have 2 chloro, dichloro, bis ethylene diamine. So 2 chloro, 2 ethylene diamine. Your platinum has an oxidation state of +4 and nitrate. So you have to determine how many nitrate needs to balance the charges of this complex ion, cation. So that's -2 +0 +4. So the whole complex ion has a charge of +2. So your nitrate needed is 2 because each nitrate carries only -1. So there you go. So you have your platinum, your 2 ethylene diamine, your 2 chloro ligand, and then the charge of this square bracket is neutralized by 2 nitrate ion counterion. Yep. And the last one is sodium hexanitro cobaltate 3. So when you see cobaltate, you know that this complex ion is an anion. It has a negative charge. Yeah. So, but how many sodium is needed? So, hexanitro. Nitro is NO2. NO2 has -1 charge each. So you have 6 of them. So that's -6. Your cobalt is cobalt 3. So -6 plus 3 gives you a complex ion with a charge of -3. Yeah. So you need 3 sodium to neutralize the -3 charge of the complex ion. So it is like this: sodium 3, cobalt, square bracket, cobalt, NO2 6. So that is sodium hexanitro-cobaltate 3. And the last one, you have tris ethylene diamine cobalt 2 sulfate. Now, ethylene diamine is a neutral ligand. Cobalt 3 will carry with it 3 plus charge. So sulfate carry with it 2 minus charge. So balance out the charges. So you're going to need 2 of these complex ion and 3 of that. How do we do that? Let me explain to you. Here. Okay. So first things first, it is a cobalt. Yep. And then you have how many ethylene diamine? 3. Yep. And then you have sulfate, SO4. We have to balance the charges. This thing here by itself is 2 minus, but this thing here is 3 plus. So how do you balance the charges? So it must be then 2 of this. So sorry, 2 of that. And this sulfate is then 3 times. Like that. Oh, that's bad. Sorry. I'll just copy paste like that. Yep. So this thing here at the bottom, if you want to see the charges, this is the charge of 2 times plus 3, and this one here for the sulfate 3 times, 3 times plus and minus 2. Yep. Must be equal to 0. 0. Yep. Are you following me? So 2 of 3 plus 3 of minus 2. The charge of the cation and anion are balanced. Yep. Go. Okay, so that's about naming. So I hope you are going to be able to name any compound that is thrown at you. Practice exercise, look at past year's papers, go through different textbooks, and you're going to get better as you as you practice more. Now let's go into structure of coordination compounds. Now in studying the geometry of coordination compounds, we often find that there is more than one way to arrange ligands around the central atom. Compounds rearranged in this fashion have distinctly different physical and chemical properties. Yep, I'm going to, I think I'm just going to stop here for a while and stop this lecture at 20 minutes. Enough for you to practice naming. My next lecture, I will start structure of coordination compounds. So you can handle naming quite comfortably. So I think I'm going to stop here. I'm going to see you in my next lecture. I think next lecture is lecture 13 because this is lecture 12. Okay, then take care, keep safe and study well. See you. Assalamualaikum.